davon aus, dass das funktioniert. And we'll switch to English and ask David on stage. Of course, we have mechanisms in Hyper-V with failover clustering. Can do live migration to migrate a virtual machine for planned maintenance from one cluster node to another cluster node. Or if one cluster node really fails, there's nothing left to migrate really, so we just restart the VM on another cluster node. But the point is, we have this entity of the cluster which the virtual machine cannot leave. We just look at Windows, Hyper-V, and failover clustering. A cluster could be one node in Essen and the other node in Munich, or on different continents, but what do you do with the storage? The virtual machine lives somewhere, represented by the VHD and other stuff. So we would have some mechanism to make that live on both locations as well, which again, we cannot do using just Windows, Hyper-V, and failover clustering. And this is exactly where SteelEye comes in. And with that, the stage is yours.
Great, thank you. As you know, my name is Dave Bermingham, and I come from the States, Philadelphia, just south of New York City. I've been in Germany now for about 2 weeks. I was at CeBIT last week, and in Hanover on Tuesday, and then here in Essen today. And I've been treated very well by my colleagues from Dresden, who've been taking me out to dinner and filling me up with beer, and swine Haxen last night, a big pile of food, and then all the sweets out here. I'm beginning to wonder if I should show up to this last dinner tonight. I've read the story Hansel and Gretel when I've been younger, and I think I might be the Hansel at dinner tomorrow. So I might have to skip and take the early flight right after the show today. So I'm from SteelEye Technology. So SteelEye Technology is a company that's focused exclusively on high availability and disaster recovery solutions across many platforms, virtual, Windows and Linux platforms. But today we're here to talk about our solution for multi-site clusters, and particularly Hyper-V. It's a solution called DataKeeper. And you know, my past history, I've been in IT since I've been in college, and like Ralph, I'm a musician in my heart. I went to university, studied jazz guitar, and I got introduced to computers early with MIDI keyboards and so forth. So I just naturally, if you play a musical instrument, you can generally play a computer just as well. I've been certified in Windows NT in 2000, 2003, and most recently I achieved my certification in Windows Server Virtualization Configuration. As a product manager for SteelEye Technology, I have really many roles. Like the technology evangelist here, I come out and promote our solutions, but I also help guide the vision of our company. And about two and a half years ago, we saw with Windows Server 2008 coming out that they really have nailed clustering and have made it easy. Have lifted many of the restrictions that used to be in place with earlier versions of clusters, where now you can mix hardware platforms, you can use virtual machines and physical servers, and so there's some self-validation process, so you don't have to go to the hardware compatibility list any longer. So it's very simple. So for SteelEye, we felt it was essential to come to market with a solution that extends and embraces the Microsoft solution. And what we saw is some of the major features of failover clustering in 2008 were enabling these multi-site clusters. So IP resources can now fail to different subnets using this OR technology. So you can have one IP address here, or if you're in a different subnet, you can have a different IP address here. They also lifted restrictions on latency on the network. So now you can have higher latency networks and still maintain the heartbeat between the nodes. But the one piece of the puzzle that they left to the third-party vendors, including SteelEye, is the replication engine. So they do not provide the replication to keep these multi-site clusters in sync. And for replication, you really have two choices. You have your hardware-based array replication solutions from EMC with their SRDF cluster extender, or the HP MSA cluster extender. So there's solutions out there, and that's great. if you have two of those arrays and you have the replication software and also the agent that enables the cluster integration, all of this adds up to be a very expensive solution and generally not a solution that is viable for the smaller businesses. Or if you have existing storage, you can't generally buy, you have to buy the same storage. So it's a solution that's available, but with our solution, we have replication that can replicate any storage. So from your fiber channel to your iSCSI to your local attached disk, and it doesn't matter. So it's a much less expensive alternative to get into it, but you still have the same high level of availability that you get with the more expensive array-based replication solutions. So let's take a look at just some of the details. I have about 5 demos, so the size will be minimal, but I think it's important to take a look at this slide here, which really is just a feature list. And we'll go through this and I'll describe it in detail a little bit more. So we are software that installs on each server, and when we talk about Hyper-V, we'll install in a parent server, and it's block level. So much like the array-based replication solutions, we don't care what the application is. If it's a VHD file, if it's a SQL file exchange, it doesn't matter. It's just blocks on the disk, so we can replicate any data type. And the way that we are implemented, we are a volume replicator, so we don't know anything about the file system. And there's the benefit of that is we don't have to deal with in-use files and locked files. So the overhead is very minimal. You'll see maybe 1–2% CPU utilization, almost no RAM, just the way we're implemented in the kernel level. So this is very, very efficient, very low overhead. And when we talk about WAN replication, so you can use our solution to replicate on a local area network, and that's fine. But if you want to extend the solution to a remote site, we can also replicate across a wide area network. We do not have high levels of requirements, so you can use your existing WAN links, and it might have latency on your links. But we've baked into the product WAN acceleration. So the same type of technology you might get with a hardware-based WAN accelerator is baked into the solution. So the latency on the line will not affect our replication. Plus we include compression and bandwidth throttling, so many of the other features you might get with those hardware accelerators are already in the product. There's 2 types of synchronous replication, and we support both types. So synchronous or asynchronous replication, and I'll just explain the difference briefly. With synchronous replication, you guarantee that there's never any data loss. So as a write comes down to the disk on the primary server, our filter driver takes a copy of that write and commits it on the target before we allow it to commit on the source. So as you might imagine, there is a little bit of overhead associated with synchronous replication. And so on a local area network, in many applications, it works just fine. Wide area network, you wouldn't want to do that because the round trip time is too long. You will notice a delay on your primary server. But if you absolutely have to guarantee that there's never a chance of a lost write, then synchronous replication is something you might want to consider. Asynchronous replication, the same write comes down, we take a copy of the write and immediately send it to the target, but we don't hold up the original write. And so at any given time, there could be writes on the wire, or if there's a very large write, we have a queue that we maintain in our filter driver, so that if I had an unexpected failure, if I pulled the power cord, anything that was still in that queue would be lost. But the data itself on the target is in a crash consistent state, so the write order integrity. So it's the same thing as if I had pulled the power cord and I plugged the server back in. It's going to boot up from an unexpected failure, your applications are going to recover, and so the data is in a crash consistent state with the asynchronous replication. The GUI we'll see in the demonstration, it's a very modern .NET 3.5 MMC snap